Ever wondered how digital electronics work? Well, let's dive into this fascinating world that forms the backbone of our technology-driven lives. At the heart of digital electronics, we find the concept of discrete signals. Unlike the continuous waves of analog signals, digital electronics utilizes discrete signals to represent information. These signals come in the form of binary digits, also known as bits, which are typically zeros and ones. This discrete nature of digital signals leads to a clear and unambiguous representation of information. You see, information in digital electronics is quantized into distinct levels. This means that continuous values are mapped to specific discrete levels through a process called quantization. Analog signals are sampled at regular intervals, and their amplitude values are rounded to the nearest discrete level. But how is the information represented? Well, in digital electronics, we use the binary number system. The binary digits, or bits, serve as the basic building blocks of this system, and each bit can have a value of 0 or 1. The use of this binary system simplifies electronic circuit design and signal processing, making it a cornerstone of digital electronics. It's this binary representation that leads us to logic gates and Boolean algebra, the fundamental components and language of digital circuits. Boolean algebra is used to express logical relationships between signals, and it's instrumental in analyzing and designing digital circuits. Also, it's important to note that digital circuits operate using switching devices, such as transistors, that are either on, represented by 1, or off, represented by 0. Through manipulating the state of these switches, logical operations are performed. So, as you can see, digital electronics is a fascinating field that combines mathematics, logic, and design to create the digital world we interact with every day. Now that you have a basic understanding of digital electronics, let's delve deeper into its characteristics. Ready to explore the fundamentals of digital electronics? Let's start with something called quantization. It's a process that maps continuous values, like the infinite shades between black and white, to distinct levels. Imagine you're trying to describe different shades of grey. You could use words like charcoal, ash, or silver. But in digital electronics, we simplify that to just black and white, or zeros and ones. That's quantization for you. It reduces ambiguity and makes the information easier to process. Now, let's introduce the stars of the show: logic gates and Boolean algebra. Logic gates are the building blocks of digital circuits. They perform basic logical functions that are fundamental to digital circuits. Think of them as the decision makers. They decide the output based on the inputs they receive. On the other hand, Boolean algebra is the math behind these decisions. It's a branch of algebra where the values of the variables are the truth values, true and false, or for our discussion 1 and 0. It's used to analyze and design digital circuits, expressing logical relationships between signals. Moving forward, let's talk about switching operations. The digital world is a binary world, a world of ones and zeros, or in terms of digital circuits, a world of switches that are either on or off. These switches are typically transistors, and they perform logical operations by changing their state, either allowing current to flow, representing a 1, or blocking it, representing a 0. You see, the beauty of digital electronics lies in its simplicity. It's all about breaking down complex information into simple binary terms, and then using logic gates and Boolean algebra to process this information. And the best part? All this happens through the simple act of switching devices on and off. With these fundamentals, you can begin to understand the inner workings of digital electronics. Wondering why digital electronics has become so prevalent in our lives? The answer lies in its numerous advantages. Firstly, digital electronics use discrete signals, typically in the form of binary digits or bits, which are either zeros or ones. This clear and unambiguous representation of information is one of the key advantages of digital electronics. Secondly, the binary system simplifies electronic circuit design and signal processing. It's like playing with building blocks, where each bit is a block that can either be a 0 or a 1. This simplicity is what makes digital electronics a winner in the world of technology. Now let's talk about noise immunity. Unlike analog signals, digital signals are much less susceptible to noise and interference. This is because digital gates regenerate signals, helping to restore signal integrity. This means that digital electronics can function effectively even in environments with high levels of interference. Another crucial advantage is error detection and correction. Digital systems can incorporate mechanisms that detect and correct errors, using redundancy and error-checking codes. This ensures the integrity of data and contributes to the reliability of digital systems. Digital electronics also boast efficient memory elements. Systems use memory elements such as flip-flops and registers to store binary information. This allows for the retention of data even when the power is turned off, making digital systems extremely convenient to use. But it doesn't stop there. Digital systems perform arithmetic and logic operations using binary representations. Circuits for addition, subtraction, multiplication, and division are implemented digitally. This allows digital systems to perform complex calculations quickly and accurately. In conclusion, the advantages of digital electronics, from noise immunity and error detection to efficient memory elements and arithmetic processing, make it a powerful tool in our technologically driven world. As you can see, digital electronics offers numerous benefits that make it an essential part of modern technology. Now, let's look at the different types of digital circuits and their applications. Digital circuits can be broadly classified into two types: combinational and sequential logic circuits. Combinational logic circuits, as the name suggests, combine inputs in a specific way to produce an output. The output is solely dependent on the present input values, without any consideration of past inputs. These circuits are the building blocks of devices that perform arithmetic operations and data transmission. On the other hand, sequential logic circuits incorporate memory elements. This means they not only consider the present input values, but also take into account the state of past inputs. They can store and process information over time, making them essential for devices that require data retention even when power is off, such as computers and smartphones. In digital systems, synchronization is of paramount importance. This is where clocking comes into play. Clock signals in a digital system ensure that different parts of the system operate in a coordinated manner. Think of the clock signal as a conductor of an orchestra, ensuring every instrument plays in harmony and on time. Now, let's move on to digital signal processing, or DSP. DSP techniques are used to manipulate and analyze digital signals. These techniques allow for efficient filtering, modulation, and analysis of signals, making it possible to extract valuable information from a sea of data. It's DSP that enables your voice to be transmitted clearly over a phone call, or for your favorite music to be streamed with high fidelity. In conclusion, the classification of digital circuits as combinational or sequential, the use of clocking for synchronization, and the application of digital signal processing techniques all contribute to the versatility and power of digital electronics. Whether it's a simple calculator or a sophisticated computer, a digital watch or a spacecraft, digital electronics play a vital role in their operation and functionality. Understanding these classifications and applications can help you appreciate the versatility of digital electronics. So, what does the future hold for digital electronics? The world of digital electronics is always evolving, and the trends that we see today will continue to shape the future. One of these trends is the increased flexibility and programmability of digital systems. With the advent of programmable devices, such as microcontrollers and field programmable gate arrays, or FPGAs, we're seeing a shift towards systems that can be reprogrammed to perform different functions. This offers immense flexibility in system design, enabling engineers to adapt and evolve their systems as needs change. Another trend shaping the future of digital electronics is the compactness and integration of digital circuits. Thanks to advances in technology, we can now integrate multiple digital components onto a single chip. This allows for complex functionality in a compact form, making digital electronics more efficient and practical for a wide range of applications. From smartphones to autonomous vehicles, the potential applications are virtually limitless. The efficient storage and transmission of digital information is another critical aspect of the future of digital electronics. Digital information can be stored and transmitted efficiently, making it ideal for applications in data storage, communication, and information processing. This efficient storage and transmission will become even more important as the amount of data we generate and consume continues to grow. Moreover, the future of digital electronics will be marked by continuous innovation and improvement. As we strive to make our devices smaller, faster, and more energy efficient, we'll continue to push the boundaries of what's possible with digital technology. We'll see new materials, new manufacturing processes, and new design approaches that will help us overcome the limitations of current technology and open up new possibilities. So, as we look to the future, one thing is clear: digital electronics will continue to play a critical role in our lives. From our smartphones and laptops to our cars and homes, digital electronics are at the heart of the technology that powers our world. As we continue to innovate and push the boundaries of technology, the role of digital electronics will only become more critical.